Hi, welcome back to my class in Advanced Statistics. For today, we will take application of the binomial probability distribution, which is a probability distribution for the discrete random variable for a binomial experiment. That is, the discrete random variable in binomial probability distribution is a binomial random variable. Consider the following problem. A study concerning the relative influence of husbands and wives in consumer purchasing reported that the husband exerts the primary influence in selecting the make of a new automobile in 70% of all new car purchases by families. Suppose that 4 families have decided to buy a new car. Letter A, what is the probability that in exactly 2 of the 4 families, the husbands will exert the primary influence in choosing the make of a car? B, what is the probability that the husband will exert the primary influence in choosing the make of a car in at least 2 of the 4 families? C, what is the probability that the husband will select the make of a car in all 4 families? In this problem, it is said that it is usually the husband who decide which make of a car or automobile to buy or purchase. And in all of the new car purchases, 70% of the purchases for a brand new automobile were decided by the husbands. And so we take this 70% as the probability of success, which is the probability that the husband will decide on the make or brand of new automobile that the family will buy. And in this problem, there are 4 families who have decided to buy a new automobile. And in letter A, we are asked the probability or the chances that exactly 2 of these 4 families will have the husbands decide which make or brand of automobile to buy. And in letter B, we are asked to find the probability that at least 2 of the 4 families will have the husbands decide for the make of a new car to buy. And in letter C, we want to find the probability that exactly 4 or all of the 4 families will have the husbands decide for the make of a new car to buy. First, we write the probability formula for computing the probability that a random variable x will take some value at binomial experiment. For the discrete random variable for a binomial experiment, the probability that that random variable will take some value x is given by combination of n taken x times the probability of success p to the power x times the probability of failure denoted by q to the power n minus x. The probability of success here is the probability that the husband will decide on the make or brand of new car to purchase for the family. And it is given that in all the new car purchases, 70% were decided by the husbands. Hence, we take 70% as the probability of success, the probability that a husband will make the decision on what brand or make of new car to purchase. And 70% in decimal number is 0.70. Q here is the probability of failure. That means the probability that it is not the husband who decides on the make or brand of new car to purchase. And the probability of failure is 1 minus P, or the complement of P. And we have 1 minus P because the probability of success plus the probability of failure is equal to 1. And that's one of the properties of binomial experiment. Hence, Q is equal to 1 minus P, where P is 0.7 subtracted from 1, we get 0.3. This is the probability that the husband will not decide on the make or brand of new car to purchase for the family. And in this problem, there are 4 families who have decided to buy a new car. So the possible values for the number of husbands who will decide on the make or brand of new car to purchase is 0 to 4. 0, that is none of the 4 families will have the husband decide on the make or brand of new car to purchase. N is 1. That means, N should be X. The possible values of the random variable X, the number of husbands who will decide on the make or brand of new car to purchase is 0 to 4. Because there are 4 families who have decided to buy a brand new car. So X 0 means that none of the husbands from the 4 families will decide on the make or brand of the new car. If X is 1, that means only one husband from the 4 families will decide on the make or brand of new car to purchase. Now we answer letter A. What is the probability that in exactly 2 of the 4 families, the husbands will exert the primary influence in choosing the make of a car? In this formula, N is equal to 4. Because there are 4 families who have decided to buy a new car, and the value of X is from 0 to N. Hence, X will take value 0, 1, 2, 3, up to N, 4. In letter A, we want the probability that exactly 2 of the husbands from the 4 families will decide on the make or brand of new car to purchase. And using this formula, we have combination of 4 taken 2. Multiplied by P, the probability of success, 0.7. To the power X, X is 2 for letter A. Multiplied by probability of failure, Q is 0.3. To the power N is 4, minus X is 2. And we compute this directly using our calculator, our scientific calculator. We start with combination of 4 taken 2. In your calculator, you have this function, combination of n taken x. And use your calculator to calculate combination of 4 taken 2. Combination of 4 taken 2 is 6 multiplied by 0.7 square. And multiplied by 0.3 square. 4 minus 2 is 2. Hence 0.3 to the power 2. And you should get 0.2646, and to 2 decimal places we write 0.26. The probability that 2 husbands from the 4 families will decide on the make or brand of new car to purchase is 0.26 or 26%. To answer letter B, what is the probability that the husband will exert the primary influence in choosing the make of a car in at least 2 of the 4 families? The problem asks for the probability that at least 2 of the 4, at least 2 husbands from the 4 families will decide on the make or brand of new car to purchase for the families. In symbols, we write the number of husbands who will decide on the make or brand of new car to purchase. At least 2, we use greater than or equal to. At least 2 means 2 is the lowest, which means that x can be greater than 2. Thus, in number 2, the probability that at least 2 husbands from 4 families will decide on the make or brand of new car to purchase is, in symbols, the probability of x greater than equal to 2. And the values of x that are greater than equal to 2 are 2, 3, and 4. And the probability that the number of husbands from 4 families who will decide on the make of new car to purchase is at least 2 is equal to probability that x is 2 plus probability that x is 3 plus probability of x is 4. And we already have the probability that x is 2, 0.26. The probability that x is 3 using this formula is equal to combination of 4 taken 3. Times p, which is 0.7 to the power x is 3. Multiply by q, 0.3. To the power n is 4 minus x is 3. 4 minus 3. Plus probability x is 4 is equal to combination of 4 taken 4. Multiply by probability of success 0.7 to the power 4. Multiply by q, probability of failure 0.3 to the power 4 minus 4 or 4 or 0.3 to the power 0. And we compute the second and the last term values using our scientific calculator. Using our scientific calculator, the value of the second term, combination of 4 taken 3, multiplied by 0.7 to the power 3, multiplied by 0.3 to the power 1, 4 minus 3 is 1, is given by 0.41 to 2 decimal places. And the value of the last term, combination of 4 taken 4, multiplied by 0.7 to the power 4, multiplied by 0.3 to the power 0, 4 minus 4 is 0, so 0.3 to the power 0 is 1. And the value of the last term is given by 0.24 in 2 decimal places. And we add these three terms, we get 0.91. And that's the probability that at least 2 husbands from the 4 families will decide on the make or brand of new car that they will purchase. 0.91 or 91%. Now, there is a second way to solve for letter B. One of the properties of probability distribution is that the sum of the probabilities corresponding to the values of the discrete random variable x is equal to 1. That is the probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3 plus probability of x equals 4 is equal to 1. As I said earlier, another way to solve for letter B is to use this property of probability distribution, the summation of the probabilities corresponding to these values of the discrete random variable x is equal to 1. But from this term up to the last term, this is the probability that x is greater than equal to 2. Plus probability x equals 1 plus probability x equals 0. And the sum of these three terms is equal to 1. And from this last equation, we can solve for probability that x is greater than equal to 2. Is equal to 1, and we transpose the probability that x equals 0 to the right hand side, and we take the opposite side of the probability of x equals 0 and becomes minus. We also transpose to the other side the probability that x equals 1, and we take the opposite sign of positive and we get minus probability of x equals 1. The advantage of using the second method for solving letter B is that you will only compute two probabilities, the probability that x equals 0 and probability that x equals 1, and subtract them from 1. While in the first method we used earlier, we have to compute for three probabilities, probability of x equals 2, probability of x equals 3, and probability x equals 4. And then we get the sum of the three probabilities. But in the second method, we only need two probabilities, probability of x equals 0 and probability x equals 1. And using the binomial probability distribution formula, probability of x equals 0 equals combination of 4 taken 0 times the probability of success, 0.7 to the power x 0 multiplied by Q, or probability of failure, to the power n minus 0. N is 4 and x is 0. Minus probability of x equals 1 is equal to combination of 4 taken 1 times the probability of success, 0.7 to the power x1 times the probability of failure, or Q, 0.3 to the power n minus x, where n is 4 and x is 1. And we compute the second and the last term using our scientific calculator. We have combination of 4 taken 0. 0.7 to the power 0 is 1, multiplied by 0.3 to the power 4. To two decimal places, you should get 0.01. And the last term, we have combination of 4 taken 3, multiplied by 0.7. Multiplied by 0.3 to the power 3, 4 minus 1 is 3. 0.3 to the power 3. And to two decimal places, you should get 0.08. And we subtract 0.01 and 0.08 from 1. We have 1 minus 0.01 minus 0.08, and we get 0.91. Which is the answer we get in the first method, 0.91. Now it's up to you to decide which of these two methods you will use. And now we answer letter C. What is the probability that all of the 4 husbands in the 4 families will decide on the make of the new car they want to purchase? And for letter C, if all of the husbands in the 4 families will decide on the make or brand of new car they want to purchase, we want the probability that x equals 4. And by formula, this is equal to combination of 4 taken 4 multiplied by P, or probability of success, 0.7 to the power x, x is 4, multiplied by Q, or probability of failure, equal to 0.3 to the power n minus x, n is 4 and x is 4. And we have already computed this in letter B. But again, we check. We have combination of 4 taken 4 multiplied by 0.7 to the power 4 multiplied by 0.3 to the power 0. And to two decimal places, you should get 0.24. Thus, the probability that all of the 4 husbands in the 4 families who are planning to buy a new car will decide on the make of the new car to purchase is 0.24 or 24%. For your practice, please try the following exercises. Number 1, in recent reports suggest that 50% of Filipinos favor PhilHealth, while 50% oppose it. Find the following probabilities if a sample of 10 people are surveyed on this issue. Letter A, none favor PhilHealth. Letter B, at least one favors PhilHealth. Letter C, 5 of the 10 favor PhilHealth. And letter D, a majority of those surveyed favor PhilHealth. There are 10 people who were surveyed, and a majority represents more than half of the 10 people surveyed. Half of the 10 people surveyed is 5, and to be considered majority, it has to be more than 5. So the majority can be 6 or more than 6. In letter C, a majority represents at least 6 people. Number 2, in a recent study of Filipinos under the age of 40, 60% favored reduction of the average work week to 40 hours. That is, in 1 week, the number of working hours is 40 hours. Average work week to 40 hours from the original of 50 hours. A group of N equals 20 Filipino workers are randomly chosen for interview. Find the following probabilities. Letter A, majority favor reduction of work week to 40 hours. There are 20 Filipinos who were chosen randomly for an interview, and a half of this is 10, and a majority represents more than 10. So the possibilities are 11, 12, up to 20. A majority represents at least 11 or above. And we want in letter A the probability that a majority favor reduction of work week to 40 hours. Letter B, at least 15 favor reduction of work week to 40 hours. And letter C, at least 10 but no more than 15 favor reduction of work week to 40 hours. And that completes our lesson for today, and that's also the completion of our lesson on binomial probability distribution. In the next lesson, we will take up the Poisson probability distribution. If you have any question about the lesson today, please ask your question in the comments below. But don't forget to subscribe to my YouTube channel, Art Calisan, the channel of learning and leisure. Thank you for joining me in my class today in Advanced Statistics.